Oh, what's up, everybody? Welcome back. Today we're working on our Wayland compositor. We are on day, 5 of this project. We're not going to try to justify why we're making one because there's no real good justification, but it's pretty fun. It's pretty fun. We are at the point, as of last stream, where we can, in a virtual machine, render one window. One window. Let's see. So here we start our window manager, Swim, and we start a client to point to that thing. This client is this client, right? So on my desktop, we have a little monkey, his head spinning. This is all running like our own custom shit. No lib Wayland or any of that thing. Everything's kind of like by hand. But here in the virtual machine, we see the same thing. He has initialized a context to render into whatever, like a DRI file handle. So he's kind of taken like the virtual terminal, been like, no, fuck virtual terminal. We're gonna make picture now. He gets a bunch of frames from the client. The client sends them through a file descriptor over like a Unix socket. He does a bunch of Wayland chatter to figure out like what he's supposed to be doing, and then he renders. This is good. However, this is not a window manager, right? We've just basically done render like our original app just with a lot of extra steps. And so today's topic is trying to make this more like a window manager, make him do something a little bit more sane. Yeah. So I think plan of action is we need to like have some sort of like background, right? Like we need like a place where we're doing rendering of the window manager itself. We are not doing that right now. We're just taking like the frame buffer that the client sent us and like displaying it directly on the screen. So step one is like get a area for us to do anything. We'll probably start with like a red background. Then we're going to try to like render this as a window. So he's going to have to be like composited somehow into this place. Maybe we can use like a plane that's available on the GPU, do hardware composition. Maybe we just have to do like a blit on GPU with like some like OpenGL program. Not sure. So then we might get into some sort of like intelligent rules for, the GPU has this many things that it can do like hardware composition with. Let's try to use those when available, but otherwise then fall back on like normal rendering. There are some GPUs that have 0 planes, and so once we kind of have like figured that out, we can probably fix those as well, and then we'll probably be at the end of the stream. So that's the plan. Fuck! I closed the VM again every goddamn time. But yeah, let's start with rendering a background. Rendering a background. So right now, our application doesn't do anything really. He's kind of more like a pipe for clients. But now we need like an OpenGL context, surely, right? We're gonna have to create like our own frame buffer to render to, and we're gonna have to display our own buffer that isn't attached to any Wayland buffers, right? Just like a thing that we own ourselves. So I think what we're gonna do is we're gonna initialize OpenGL in the same way that we do in our client, right? We have a Wayland client, Windows maybe is where this lives. He creates, he uses Mesa. We're assuming right now that we're on a device that can use GBM. So GBM is like, okay. Context. So like, I have, you have like a GPU, right? Someone's got to talk to this guy from your CPU, right? So someone's got to like manage, how do I like put buffers on this guy over PCI and all that, right? So you have like assorted like drivers, right? Drivers. And depending on your car, you're gonna have a different driver, right? Most of the Linux graphics drivers all use Mesa, right? They're all the same guy wearing different masks, right? Which is just like an open source Linux driver thing. Mesa is kind of like the user space side of the driver. Unlike most drivers, GPUs are complex and kind of performance sensitive enough that you kind of want your drivers doing a lot in user space, because you don't want all of the complexity in the kernel, and you don't want to like have like a billion syscalls going all the way, right? So you do a lot of the stuff in user space and then kind of like use the kernel for when you actually have to talk to the GPU. So like, convert, like doing like OpenGL like shader compilation and like buffer management and like pipeline setup. Like a lot of that stuff lives in user space here. On NVIDIA, you have like your own driver, and you might have like AMD GPU Pro drivers or whatever as well. Mesa owns this library GBM, which is like I think stands for generic buffer management. And so what happens here is like NVIDIA also just implements libGBM support. So we should be able to, on like basically any Linux system, if we say like make a generic buffer that is like frame buffer, right? Just like a place for us to draw. Make a GBM handle this thing. We can create like an OpenGL context with this library called EGL. We can say, hey, make a window that points to the same buffer, and then we like interact with this guy when we send him over to the server, or when we want to like display him on the screen using like the Linux DRM system or whatever. Like we just have a buffer here in like a generic format that we know how to export. So we should be able to do the same thing here. I assume the user space side is what has a stable API. Yeah, so kind of like Mesa and NVIDIA, their APIs, like their APIs are like Vulkan, right? Or OpenGL, right? So these are like stable, but like implementations of these guys are like completely, you know, free to do whatever the fuck they want as long as they export, you know, OpenGL or Vulkan, or in some cases, I don't know how like Proton works with like Direct 3D on Linux. I don't know if that's like someone else or if that's also part of Mesa. I'm not sure about that. But anyways, so we should just be able to copy paste this part where we're like, just initialize OpenGL backed by some GBM buffer. We should just be able to yoinkies that and stick it over here somewhere. Probably. Which means I think that we're going to copy paste the system file, which has like our GBM and OpenGL context, because I think that our use cases are a little bit different than on the client. So I'm just going to like, yoinkies this over, and we're going to call it something else though. We're going to call this like systemgl or something, you know, something like that. Something like that. Cool. So this creates a 640 by 40 buffer, hard coded to dev DRI card 0. That's pretty bad. And he hard codes XRGB 888 back buffer, which are like, you know, surface, whatever you want to call it, which is fine. That's fine. And then we find an EGL config that matches this thing. We need to pick a better, like, we need to like pick resolution based off render backend. Actually, we can do this right now. So our render backend, he just needs to expose a function that's like, hold on. He needs to expose a function that's like, what is my current mode? So this guy is here. He's gonna say like current resolution. Who probably takes in all the typical, you know, pieces and returns a resolution. Sure. And in here, I wonder if there's like supposed to be color format in here. There might be, but fuck it. I think they translate to Vulkan. I think DXVK is non-Mesa. See, read Proton and like Wine stuff. That's external, and they just do like a direct 3D to a Vulkan translation layer. Makes sense. Let's just do this for now. We'll just do returns a width by height. Maybe like mode info might be a better name for this, but like fuck it. And this is current resolution. FD stood POSIX FDT, and this is like call this thing in the v table with the parameters that we pass in. And sure, I think letting this be failable is fine. And then this thing needs to return resolution as well, and this needs to return here. All right. So now everybody who implements this DRM rendering backend needs to have like current resolution, and he needs to implement this thing, which is fine. Should be easy peasy. So this is like current resolution returns a rendering resolution. Great. And it should be like convert this to self. So this is a DRM, is a pointer cast, a line cast of context, and we just return rendering like self dot preferred mode. I think it's like H display and V display. Yeah. That seems fine. Something like this. And then we have multiple render backends now, which is kind of hype. New feature compared to last stream. We have a null backend now, which allows us to do testing without being in the virtual machine environment. I was like doing some off-stream work, it was like pissing me the fuck off. So we implemented this. But we'll just make it so that the null version of this thing will return probably just a hard-coded like small window or something. You know, we'll just make them like be like return width is 640, height is 40 or something. Just let him do whatever the fuck he feels like. Maybe in the future we'll make it so that this null guy like exports an image every once in a while. That might be kind of interesting, so that even when we don't have like, you know, we're not in an environment that's super straightforward, we could still like check that the output is like semi-sane. That'd be kind of cool. This system GL thing needs a C bindings thing. What the fuck is that? Window bindings? Is that what this is? C bindings.h? Yeah, this is what we want. This is what we want. Make, we'll call this like system GL bindings or something. This is someone who returns a std build module. We do this shit here, and we just return this, I guess. And then this make window thing needs the like GL bindings here. Who gets this guy? Boom. I guess, yeah, it's fine. We'll call it that for now. And then we do the same thing on our window manager. So we're like, give me some fucking GL bindings, please. And then whoever calls this needs to pass those system GL bindings here. And probably, who's the other guy who wants them? Window. So here as well. Make system GL bindings. Boom. All right. Does that build now? Whoa, what's he pissed about? We need to link this thing with the correct stuff. So if we have this stuff, we do this. Much better. Much better. Okay, so we should, if I run zig build and zig out, maybe this, yeah. Okay, so we failed to initialize. That's not good. I was expecting to see something a little bit more sane here. So I think that like nothing like explicitly failed, just the OpenGL driver stuff failed. I think technically, we're like, since we're opening the same card twice, he might not like that. So it might be that like here, we're supposed to call in like device F, like maybe we pass this in. It would be interesting to see what happens if we do this instead, because we already have this as part of our render context, right? So here, can we be like, yo, use the render backend event FD for this thing? No, that won't work because we're using the null backend. Huh. So that's actually not what's happening because we are failing to open this card already. This might be like we might be supposed to we're using a render node. So here it's like there are different permissions on if you use card 0 versus render node. Render nodes have the ability to do OpenGL rendering, but they don't have the ability to do like display management. So I suspect that it's something like that. For now, let's just hardcode render D128 for now. Let's see if he likes that a little bit better. And this should be, we should be getting like the preferred size here is render backend dot current resolution. And then we're like preferred size width and preferred size height here. Okay, nice. What the fuck just happened? What is happening? This is supposed to be like this. Then here, this is mad because we've just lost the context somehow. I don't know what the fuck happened. What is happening? I must have typed something by mistake, but this is working now. Okay, so if we run this thing, he now is no longer complaining about, like here he was complaining about AMD GPU initialization. Here he's fine. So I think we're chilling. I think. So we should be able to now like just call OpenGL shit. So can we just call like GL clear? Do we have OpenGL bindings right now in that like header file? I think that we had like separated out. Yeah, we had this kind of separated out a little bit, which is fine. We can make this work again. Source, swim. Let's just throw a gl.h in here and do another translate C. gl.h. It's fine. It's fine. We'll throw this here. This comes from swim gl.h, and in reality, this could all have been one header. Can we do that instead? Let's do that. I don't like what we did here. Who calls this? egl.h, like, what the fuck? Can we just do this? I think that this is fine. Let's do this. So fuck this. Whatever we did before to make these, like, GL bindings, just get the fuck out of here. I don't like it. Oopsies. I don't like it. We'll just do it like this instead. Okay. But we did forget that we have to link these libraries directly now. What is it? libgbm and EGL and GL now for regular OpenGL shit. Okay. So now let's just try to like clear the screen. Let's just do that. Let's just do a little somewhere. Can we go like system GL? I want this to just, whoa. GL binding. Can we just call this like import GL? I don't know, man. This is kind of fucked for now. But can we just like GL clear color 1001 for red and GL clear with the color buffer bit. And what we want to do now is find some way to get this to show up somewhere. So let's go back and look at the client where we've done this before. And I think that we call like EGL swap buffers. Sounds familiar? So this is what we do here. We swap, lock the front buffer, and then create, we say 2 buff params. No. Front buff is lock front. Okay, it's just this. This is all we need. Theoretically, this is all we need. So we should be able to, I guess we call swap buffers on this kind of like every frame in the renderer, probably. Probably, but for now we'll just do it once. Let's get the front buffer out. So we take this guy, we say, okay, we have a buffer now, and we won't free it right now. All I want to do is like see this somewhere. So we want to like feed this into the renderer probably. Yeah. I think we just want to do this. EGL context is EGL context, and GBM context. These are pointers probably. And we're going to have to like get this buffer out and track it somehow. Don't know how yet. Don't know how yet. So in the renderer, every once in a while when we have stuff to do, I think that we, right now, let's just pretend that this is the only buffer we care about. I think that will be easier. And so in here, we're going to do like, I think we need to keep track of, okay, I'm going to paste this just so we don't lose it. We need to keep track of like compositor wants render. So this is a bool, or compositor locked maybe. As soon as the compositor buffer gets unlocked, we will render again, or something like that. We will then also hold onto an EGL context, which is from system GL EGL context, pointer, and a GBM context. Which we haven't figured out yet, but it's okay, we'll get there. Okay. Then, this needs a better name, by the way. I don't like the name system GL, because that's confusing if it's like C bindings or like system layer. So we'll just throw a fixie on that. It's pissing me off. It's pissing me off. Okay, so we're gonna be like, if self compositor locked, if this is unlocked, we will, you know, get the latest shit. GBM context or something, right? And I guess we probably need to stash that thing for later, because I think we need to like return this buffer later. So we have like GBM context dot unlock with a buffer. So is front buff the buffer? What is this? Yeah. So we'll call this like, you know, locked buff here is a system GL GBM context buffer probably. Cool. So this is like, front buff is this. If there's an error in this section, then I guess we probably do this, right? Give it back. But otherwise, at some point, we're going to say self locked buff is equal to the front buffer. Remember that shit? And I guess we just call display buffer with this thing, right? So this is like, yo, we're going to use our self compositor locked as our thing here. This should be like better names. It's going to look something like this. And we just need to convert this thing into like whatever format this guy wants, right? So this is, you know, front buff file descriptor. We have, you know, whatever else. Let's comment out this stuff down here for a second. Okay. And let's just start compiling and see who bitches. Is it called this? That's stupid. Build.zig. This should be called like GL or something. Bum, 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 bum. All right. Composer locked is false here by default, and locked buff is null, I guess, by default. Undefined, I guess. I guess this should be null, I guess. So if we have one of these buffers, we need to return it at the beginning. Something like this. Then we do our swap, we get the new buffer, we try to display it, and then presumably this is going to yell at me that there's a bunch of missing stuff here. This is mad because this is not a failable function, so we're just going to make it failable for now. That's just easier. So if, you know, self pull, we need to pull self here, self comes here like this, as a whatever the fuck this thing is, a renderer. Yeah. We say, try to do whatever the fuck you were doing. And if you fail, return, fuck my shit up. Otherwise, return, keep going in the future. Cool. Then this is just return now. This can be tried now. Wonderful. No more of this hack. Everyone can just actually fucking try. Cool. So now this guy's like no field FD, right? So we need to call a function on this thing to get that. Cool. Modifiers is front buff modifier. Should be modifier singular. Whatever. Offset is offset probably. Plain IDX is plain. Do we have plain? Zero. Fix me hack. Assume plain 0. I think this is not right, by the way. I think that's not right. But is that what we do in the client right now? Yeah. Yep, it is. Okay. What else are we missing? Stride. Cool. What else? Width. Front buff width. Height is height, probably. Format is format. And then everything else, I think, just kind of works. Looks like int casts need to come out here. Looks like. And he's saying that this thing is expected to be attached to a WL buffer. This is not the case, but fix me. WL buffer should be tracked somewhere else, probably. Because we are not a Wayland buffer anymore. Not everybody has to be a Wayland buffer, sir. Okay, so let's just kind of, we need to do this in the VM, I guess, so that we actually can see something happening. Maybe we go over here and we call SSH here and swim. Okay, so that's not good. Nobody's attempting to render ever because we are only rendering in response to a vflip. And before we would like start vflipping when we would render when somebody like asked us to render something, but that's not the case anymore. So we need to kind of say that if we're in the init case, I think it's like we kind of do this. So we do like this render stuff. If we are ready to render, and then if this thing is readable, then we will like update our flags. I think that makes sense. We'll see if that works. Okay, DRM ioctl mode create dumb permission denied is interesting. That's interesting. Do that, yeah. So oh, are we looking at the wrong display? No. Huh. Who's calling that? Because as far as I understand, are we getting into this guy? We must be. Okay, let's go to DRM render backend. Did we see any like evidence of failure anywhere? No, right? He just said he just complained like visibly, but nothing like failed, which is interesting. So can we look at like rendering buffer? Like, is this happening? It must be, right? It must be. It's gotta be. No. Okay, so that's interesting. Because I also don't see anybody like complaining. Like, why the fuck? This has to be happening, right? Is this thing initialized with true or something? No. It means that this stuff must be failing? Oh. This, we're just not fucking writing down when people get angry. Failed to pull, here's why. I'm an idiot. We do need to log our failures to see them. You have to run the code that you want to run. That's a classic. Yeah, okay. So we're seeing swap failed here. So EGL swap buffers is returning, yo, I can't fucking swap because he is failing to create dumb buffer. Which is confusing to me because he has like a GBM buffer. So I guess that's interesting. So I guess that means that using the render node was wrong, right? When we change that to say like render D128 or whatever. Can we go back to card 0 here? Just for a second. I just want to see what happens there. Oh wait, here we go. We're so back, baby. There's a little there's a little fucking red screen. That's hype. So we should be able to now, I think, if we start like changing that color every once in a while, right? So in our like main renderer, can we just do something like pulse it? Right, so we kind of do like our GL shit here. There we go, that's better. So can we do something that's like, I would love to keep track of our timestamp here, so we can kind of do here. And we can say like, delta is now since last, and we can do this as delta ns. Const delta is a float is, you know, float from int delta ns over stood time ns per second. And now we can kind of just like pulse this thing a little bit. So can we just like change the red value like once per second? So can we do, just for now, self are it like background red is plus equals is equal to like the current background red plus delta, and then can we just do like an fmod on here? Something like this. This is good enough for now. Good enough for now. Fix me, debug, remove later. Background red f32 equals 0. Off rip or something, right? Hello? Oh, background red. My bad. Okay, cross compile this thing, copy it over, run it. So we should start to see this thing like kind of start red. No. So that's interesting. So if we start this thing fully red, does that kind of do something? No? What the fuck changed? Hold on. Apply the delta after. Am I fucking stupid? Okay, okay, so we are getting something shown. Is it that the delta here is wrong? Delta ns now since last. Okay. Let's do this for now. For now, self background red. Let's just make sure that like it's supposed to be changing and it's just fucking up for whatever reason. This is only getting called one time. That's the fucking problem. Is we're not fucking page flipping. Why not? So we're probably waking up and like what this is not unlocking because we haven't serviced yet. Of course. Of course. This needs to go down here because service is what will tell us that this guy's ready to go again. And we have to read this. We have to run this if possible. So what we should really do is we should split this out into like render, you know, compositor or something. Right? So this is a renderer. And this gets everything in here. And then we call this here. And in the init case. Or maybe even here. On like init. Yeah, it's like if reason is initialized, this is the first call, we'll render it. Cool. And then this guy gets an instant in here. Different now because now was inside if before. Yeah, but that's okay. I'm okay with that. I'm okay with that. But good eye. Thank you for the 200 bits. Much appreciated. Okay. There we go. Okay, so we have some evidence now that we have like an OpenGL loop. Uh-oh. So there was some evidence that this thing does do something, but it looks like eventually he's freaking out. So we should just make it so that maybe every once in a while, maybe this is like a spurious failure. So what we should do is when we should never, ever let this guy die. Or else we will just die forever. So that's bad, because we'll just stop rendering on the first error. So let's just see if that's like a spurious error, or... And it looks like it, right? It looks like, oh, no. DRM returning create So here, oh, interesting. So now he's never waking up as well because we never queued the flip. So even though this thing would still poll, we never got the page flip queued, and so the VSync is never happening, which is interesting. So maybe like also this guy should be polled like on a timer in the worst case, right? I think that we have, you know, here we can replace handler with a different handler. So you could theoretically be like run it on a timer instead. In the case that we failed. And then like once that succeeds, run it on the page flip handler instead. But let's not go there first. Let's try to fix whatever the bug is that's causing this thing. So he's saying returning create handle due to 9. Okay, so let's look at that. Returning it's in here. Or due to here. So we need to look at our Erno numbers. So this is him going create handle. So he is failing to import this DRI prime handle. Okay. So can we look at Erno numbers again? What is 9? Bad file number. Interesting. Okay, I am curious what happens if we don't. I was worried about like resource cleanup earlier. I'm just curious what happens if we don't try to do resource cleanup. See, I want to know if that behaves like kind of differently. 3 Mississippi, 4 Mississippi. No, so we get the same problem, right? So no matter what, he's like, yo, this is not a valid file. So does that mean that, like, what is happening here? We are calling swap. We are getting some file descriptor out from the GBM context, right? We have this like lock front thing, and this thing, I guess, returns a buffer that we call file descriptor on, and we call GBM BO get FD. So it could be that this guy is failing for some reason. Can we look at like the docs for this guy? We have this somewhere. It's like in here somewhere. Okay, returns a file descriptor or -1, right? So it's possible he's returning -1. Right? Very, very possible. So if I guess we have like this, you know. Boom, boom, boom. If ret is less than 0, return error bad f, right? Then we return ret. Okay, then the caller of this thing is going to be like, try here, and then this will fail, hopefully. Hopefully we're seeing like an actual bad file descriptor, because that's something that we can like diagnose a little bit better than if like GBM exports a good file descriptor, but like the compositor isn't happy with it for some fucking reason, or like the DRM system isn't happy with it, you know? Okay, so that's good. Failed to pull, bad file descriptor, right? So we now know that GBM is aware of this. So I guess the question is why can that happen? So are there like logs that we can turn on in GBM, or like code we can inspect, right? We want to do something like that. So can we look at like BO get FD? Who implements this thing in Mesa? This is probably like this. Okay. So this guy, he might have a null image. It doesn't look like we get nice logs in here, right? It would just be like one of these. Okay. And then we also have this guy. Let's kind of like walk down here somewhere. So someone turns this thing into this thing probably, and then we need to probably go up a layer here. No. Interesting. I feel like we last time found this. Oh, it's because I had the fucking semicolon there. There we go. So this guy probably makes it into this implementer, would be my guess. And then we're probably looking for this guy. This can fail here, I guess. So can we look for who implements this? We are looking at we are in a VirtIO GPU driver somewhere. So KMS DRI WinSys sounds kind of likely. Yeah, we might be here. Software, DRI software seems likely. Is there a way that we can confirm like whose driver we're in? There's probably like some like Mesa environment variables that we can turn on to see which driver is loaded. libgl debug is verbose. We can just try that first, right? libgl debug is verbose. Dude, I don't know how the fuck people work with closed source libraries. Like, I don't like. It's so important to me to just be able to like look at the code. This is not really telling me what I want to know. Is there like, Mesa debug? Mesa log level. Like, someone's got to tell me like which fucking driver we're running. Well, I guess we could do like EGL info as well. GL info. Who Mesa demos, APK at search Mesa. Is there something like that? Mesa demos, yeah. All right. Let's look. Let's look to see what fucking driver is this VM using, because that'll give us some clues of where to look. It would also be nice if we could compile our own Mesa to like inspect a little bit, but I don't really want to. That's too much work. Fuck. Okay, we do have EGL info, which is nice. So this will give us some clues, probably. Oh my god. Okay. So we have KMS, kernel mode setting software rasterizer, right? So that was a good guess here, that we are in kernel mode setting software rasterizer. So that lines up with his like, issues before with like failing to get DOM buffers. So it's possible that we have to close these. It's possible that every time we swap, he's like creating a new file descriptor for this thing. And I guess we aren't closing it. We aren't closing it. We have to close it, no? Because when we call unlock, I mean, but like, is it not? Oh. Yeah, is it like not the responsibility of GBM to manage his own internal buffers? Right, I would think that like we're not supposed to close this file handle. But we could check if the number of file descriptors that we have is like exploding and GBM's like getting upset about that, maybe? Right, that's a thing that we could like look into. So we could call like, swim this thing. We can SSH this again, and we can like ls proc pgrep swim fd. Yeah, I mean, that doesn't look promising, right? We're fucking at 999. It seems unlikely that we are doing the right thing here. I'll fucking say it. Yeah, that's surprising. Oh, wait, no, that's not surprising. We knew this. I just forgot. We're supposed to close this file descriptor. That's in the docs somewhere. That's in the docs. gbm.c get fd, right? It says here somewhere, returns a new file descriptor and the caller is responsible for closing it. We just didn't fucking do that. Fucking dumbass. So that's probably where we're fucking up. It's probably error, huh? So we probably have to do this. It's like const render buffer is a rendering, like render buffer here. We take this stuff, slap it up here. Every time we create a new file descriptor, it makes a new one. So we do defer render buffer buffd stood POSIX close, and then we pass in this guy here. Like this. Boom, 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 boom. All right. I mean, that's a nice fix. If that's it, all it is, then that's really straightforward, right? Easy fix. Wait, does he? Yeah. Oh, God. Again. All right. We chilling now? So 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi. Yeah, I think we're chilling. And it looks like, you know, this is relatively stable. So I think we're chilling. Cool. I would say that is a background rendered. Cool. Okay. So now someone's going to connect to us right now. What's running inside the VM? Just the window manager. Window manager. So if we try to attach a client now, not found. What do you mean not found? No, yeah, what the fuck are you talking about? What the fuck is he, what is he talking about? Oh. No, I don't understand. I don't understand. Something's changed. It must be like how we changed like the linking setup here. Yeah, there must be something like that. What is he complaining about? Get context, symbol not found. So he's, yeah, something here. I assume it's like when we did this linker change here. I think that the translate C stuff doesn't correctly resolve in the same way that everything else does, so it could be something related to that. No? Okay, hold on. Git diff build zig. What did we change here? Not a lot. Oh, I guess we just installed stuff. We did install stuff, which could have changed something. So we might have to resync the rootfs here that we're using when we're linking. Maybe. Could be. No. I don't understand. We didn't. I really don't understand. Git stash. Like, this was working a minute ago, at the very least. Very confusing. When we did that, like, install shit, what did it do? Because surely that's related. I think we just fucked something up. Cannot find dynamic linking. Yeah, I mean, I agree. I've seen that before. But can we, how do you like dump the imports directly? There's like a readelf shit, right? Readelf dump share libs or something. Readelf-d. Okay. So can I do that in the VM as well? Read ape. Oh my god. Search read elf. It's like elf utils probably, right? Bin utils? Probably. Okay. So like, I should have LD Linux x86, right? If I look at like ls lib ld LD Musil. But aren't we compiling for Musil? Musil here. Unless like somehow we like cross compile. Like, yeah. What the fuck is going on? And then also, why does swim work? Right? Swim does resolve LD Musil here. Like something is fucked, right? Because like this guy is looking at Nick's store, and the server isn't. You know what I mean? I'm worried that it's a cache issue. Just like, you know, on a whim, it seems like the type of thing that there could be a caching bug in, right? Does kind of seem like that. Yeah, okay. So there was some sort of like import caching thing, probably related to importing on the Translate C. I know that the Translate C stuff doesn't correctly resolve system libraries. So I think that it's likely that there was like some caching issue where the module imports like weren't resolved the way that they should have been. Okay. So we're back. We have this guy, and we should see if we run our client now that like he talks to him, but nothing ever gets rendered. Oh, that's kind of fun. I saw one frame of a monkey there, which is actually quite surprising. I didn't think that would happen with like the code that we have in here. Oh, because when we first get a buffer, we do ask him to render it. I remember now, right? Like we were saying before, that init case is handled when the rendering thing is pushed somewhere. So it's like the Wayland client notices that he has a buffer to commit. And in compositor state, probably, when we push renderable, we might display buffer. Yeah, we just shouldn't do that anymore. Yeah, okay. So we now have to, in our render loop, we need to like look at all of these guys, and for now, can we just like render them directly into our texture? So like in here, when we render compositor, we should go over each of our buffers. So we should say, get me the latest and greatest, who will pull from the latest buffers if they are available for us and that we are unlocked, so the GPU is not using them. Great. Then we should iterate over everything. We should say for self compositor state, you know, renderables that are ready to, like, this could be called lockable buffers, to be honest. That's a better name for this because they're not necessarily locked just because they're in there. So we should be able to look over these guys. We should be like var lockable, or I guess like this is going to be like the surface iterator, renderable iterator, I guess. Iterate over each renderable thing. And the intent behind this guy is that we can render them in any order. Like these things will be, these are just like a list of every single surface and where we should render them is kind of like the intent here. And they can be rendered in any order as long as the depth of them is like handled somewhere. We don't have that right now, but hopefully one day. One day. So I don't know if swap buffers blocks. It might. Like, does this block until everything's rendered? Because if so, it means that by the time we are done here, that the GPU is finished with these things and we don't have to keep them locked. I'm not 100% sure on that. So for now, we will lock these things and yeah, I'm gonna say maybe not. Everything's single threaded, so I think I will just say fix me. Pretty sure EGL swap buffers guarantees that all textures are no longer in use. But we need to double check that. We need to check that. Which means this means lockable buffers doesn't need to be lockable unless we feed some pieces directly to DRM for hardware composition. Something like that. Something like that. But for now, we're just going to take each one and we just like create a texture out of this thing. So what do we have? We have like a DRM buffer. So I know that there's like a GBM import. There's also an EGL import, I think. EGL, there's this guy that allows export. I'm pretty sure there's one for import as well. DRM image, maybe? Create DRM image Mesa. New tokens are Mesa. I think Mesa's wrong. I think we want like DRI prime or something. I've seen it somewhere. Maybe DMA buff import. This sounds like it. So this guy allows us to do EGL query DMA buff formats. No. We don't want query. We want like a import. But this like modifies something. So in a add to section 251 of EGL image specification. If target is this, both or neither of the following attribute values may be given. Yeah. So whatever is in EGL 1.2.5.1, this is what modifies it. This is not helpful. Not helpful. Can we look for like EGL? He's saying modify EGL spec what? Chapter 2 of EGL 1.2. EGL 1.2 spec. Okay, so we're looking for chapter 2.5.1, right? So 2... Nope. EGL specification. Operation. What version is this? Version 1.2? Oh, is this already like this relies on something else though, right? So we need this maybe is where this thing goes. EGL image base. So he probably adds 2.5 EGL images. Here we go. So we have EGL 2.5.1 create image KHR, right? So we're probably building on that thing, right? So here he's saying add to this if target is that, right? So we're adding to create image with target of this newly defined thing and this guy, which is this thing. So I think that we just can raw create a texture, like an EGL image out of this thing. Right, so we can kind of do something like this. EGL create image KHR. I think that we need to say in our GL header here that we want these things. Prototypes. EGLX prototypes, yeah. So this should make it so that we have that, I think. Can we go maybe force a reimport? Okay. Oh, I'm sorry. It's this. There we go. Nice. So we have this function. And we call it with display. So this is self EGL context display. Great. We have a context. So what is, I think I saw in here that he wants context to be null. So if target is this guy, which is the new target, right? So, you know, we are trying to get this thing from somewhere. So if the target is that, where was that? If target is this, both or neither of the following attribute values may be given. These attribute values together form an unsigned 64-bit value called the format modifier. Okay, so this is the modifier shit. Format modifiers are specified for DM4CC, blah, blah, blah. Modifiers may modify any attribute of a buffer import, including, but not limited to, adding extra planes. Okay, blah, blah, blah. Implementations are required to validate the full combination of these things. Okay. I feel like I saw somewhere that I'm not supposed to specify width and height. I don't know where I would have seen that, though. DMA. Can we search for this? All right. Can we look for, like, example, maybe? I feel like I'm losing my fucking mind. We need an example. Yeah, so he does this, right? So I do remember seeing this somewhere. So he uses both null here for this, and then it all goes in the attribute list like this, like you would expect, to some extent. Okay. So this is a bunch of EGL ints, if I remember correctly. We want a slice of these things. And it's like GL, EGL. Can we just copy this? This doesn't have modifiers on it. So we're going to have to try to import with modifiers as well if we have them. But we'll figure that out. Okay, so we're looking at... Wait, did we not get everything? Width and height as well. Okay. Width here is going to be... I guess we need to export our back... Well, we have that, right? We did lock front somewhere. Oh, but we're importing from someone else. So we're looking at renderable buffer width here. Renderable buffer height here. We're looking at renderable buffer format here. Renderable buffer buff FD. Renderable buffer offset. Renderable buffer stride, we called it here. And then we're missing some stuff here. Right? We're missing like modifiers and plane. Oh, but plane 0, it's implied here that this is one plane. Okay, cool. So this should be a bitcast, I think. For these, all these guys. Pretty sure. And then we just need the modifiers, right? So someone in here says that they add these modifier low and modifier high. So low is going to be as renderable buffer modifiers shifted left by this is just truncated, I think. And then this is the same thing, but with this thing shifted right by 32 for the high bits. It's like something like this. He doesn't. Oh my god. There, is he happy now? Ew. Ew, but whatever. Okay, so we should be able to like feed this thing in here. And buffer, I think that they want null as well, right? Okay. Does that compile? Does that compile? Y shifted left right by 32? Because it's a 64-bit thing that's being split into two 32-bit values. It's like, sorry, we've seen this before, so like it's like in my head already. Like modifiers is 64, but this thing only takes U32s, so you have to like reconstruct him basically. Why does this have to be constant like that? Are these not modifiable? I guess this is this is like a oh, I see. Does this guy take in constant or non-const? Oh, he's fine. He's constant, so we're chilling. We can do it this way. Okay. Undefined symbol, EGL create image KHR. That's surprising. That's not good. Do we need to link with like EGLX? Or is it that our implementation in Mesa doesn't define it? Either one of those is not good. I'm surprised, for sure. Maybe we need to, maybe it's like, we need to dynamically pull this thing out. That's like not 100% unlikely. Where is this example? He's also not using KHR. So maybe that's like kind of like an old way. Let's try this for a second. Okay. Expected this, found I32. Whoa. EGL attrib, interesting. Which means this can just come in like this, I think. No more bit casting. Okay. Sketchy, I feel like, but we'll see. All right. So I just want to see if, I guess we're trying to see if this if this like runs at all. So it looks like this is going okay. Everyone's just kind of saying stuff, which means that everyone's kind of happy. I guess we don't know if this EGL create image call fails because we're not checking the return value, right? So this guy returns what? An EGL image. So I guess we need to check if EGL image is equal to EGL image none or something. EGL no image, probably. EGL create image. Like, let's look at this thing. Returns. Yeah, returns EGL no image on failure. Can we just do like std log error? Fail to import buff. Bitcast is the same as transmute and rust. Just no type check. Just check what it is. I think it's more like like I think of it as like U32 to I32 cast, but not U32 to U16, and not like arbitrary struct to arbitrary struct. I think, but it might be more advanced than that. Not sure. Not sure. Okay, so if we have this image, we should be able to like turn it into an OpenGL texture somehow. EGL image to OpenGL texture. There's like a way to do this. We call this guy. Okay, so what does this do? This extension provides a mechanism for creating a texture and render buffer objects sharing storage with specified EGL image objects. Great. How does it work? New procedures. Target texture this and target render buffer. So this thing defines an entire two-dimensional texture array. All properties of the texture, including width, height, format, bar, map levels, and all that, are taken from the specified EGL image, rather than from the client or the frame buffer. What is EGL image OES? Is this different than an EGL image? Seems like it might be. Any existing image arrays associated with any bitmap levels in the texture object are freed. Whoa, wait. Rather than from the client or frame buffer. Any existing image arrays associated with any bitmap levels in the texture object are freed as if text image was called for each. Oh, sure. Sure. So we like bind a texture and then replace it with this stuff, and it releases anything that was previously in the texture. Currently, target must be texture 2D, blah, blah, blah. And image must be the handle of valid EGL image resource. Cast into the type of this. Sure, so we just take EGL image and cast it. Assuming no errors are generated, the newly texture will be an EGL image target of the specified this. If an application later respecifies any image array, blah, 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 blah. We are not going to do that, so I don't care. Okay. So we just call this. And I think that, so we need to like create a texture. It's been a minute. It's been a minute since we've done this shit manually. I'm basically looking for this. GLGen textures, bind texture. It's really just this, huh? Because we're getting all of the parameters of the texture from the EGL image, it said. So we have like var texture is a GL int probably. Can we set this like GL texture invalid or something? I think there's a GL invalid texture handle. There's something for it. Whatever. 0. Okay, so we bind this thing. This is a GLU int, my bad. Right? And then we should be able to call this function with target of texture 2D, right? So we should be able to be like, I think we also have to defer GL delete textures, maybe? You know, like this. Then what are we doing? We call EGL. It was like something 2 does. Where was that spec? Here. This thing. Boom. So he's like, call it with GL texture 2D. GL texture 2D or what? It doesn't say GL texture 2D here. Can we look for this example? I just want like an example. I just want to see like GL texture, yeah, they're prefixing with this. But also, they're saying to use external OES, which is not what the spec said. We're gonna use texture 2D for a minute, and we'll see what happens. Oh wait, here it is. Accepted as the target parameter of bind texture, and EGL image texture 2 does. Wait. So this isn't here. What is this for? The texture target can only be specified using an EGL image. There is no support for most of the functions that manipulate other texture targets. Wait, so then why does it say texture 2D? Whoa. Were we looking at like two different specs? Yeah, we have EGL image here and EGL image external. Jesus Christ. I guess we're external, no? I think we want to be an external. That sounds right. Right? It's surely like this? Right? Is that what this guy does in this like fucking thing? Oh, you don't even create the texture first. You just use that as your texture source later, probably. Right, so this binds to like a name of whatever the fuck this is. Why doesn't he like this? GL texture external OES. Like, what are we missing? It's not defined. Is there like another header? Like, can we... Oopsies. External. Okay, so not here. Not here. Like in this? No. Is it in here somewhere? Can we just grep this folder? Texture... External. Interesting. So it's in the Glez 2 shit? Interesting. Do those like collide? It's confusing. Because I don't think that we're using Glez. I think we're using GL. Where I think Glez is like embedded, like for like phones and shit, which eventually we might want to, but like I don't think, like, can you import both at once? Surely not, right? I would assume no. I assume you have to pick one or the other. Which makes me think that we should just use texture 2D. That's where I'm leaning. And I'm also kind of leaning based off what we saw there, to say that we don't have to create the texture first. No. I think you do. I don't know, man. We'll fucking figure it out. Okay, so this thing doesn't exist. Also. Because I guess, like... I swear we've done this somewhere. It was in this project. It was in this project. Hold on. If we look at the diff here... Can we look for 2 does? EGL image? I swear... 2 does. EGL image. Like, I swear we did this. Like, I think it was here. I just want to, like, show this commit. Can we just go look at these, like, GL helpers? Oh, this was export. This was export, not import. Ugh. Ugh. It's so confusing. Can we look at, like... I just want, like... Mesa desktop or something. I don't know, man. Like, this seems familiar. Or this seems interesting. Mutter. Once reach Wayland, blah, blah, blah. Do they have, like, an example in the code somewhere? We could look. In some code for how other people use this shit. So can we just look here? Can we just, like, open this fucking file? I want to look at the file. Let me show the view file. There we go. What do these guys do in GNOME Mutter? Okay. Here, so they are using Glez, which is interesting. But then they are manually importing this thing, right? So they have this function here, which they call with bind. They bind the texture, then copy it over. Okay. Okay. So I want to try just doing this, like, proc address version of the thing. Can we just do this for a second? So here we define this as, like, what is it? It's we still need the other fucking header. No, it's gotta be in here. Target texture. What the hell? These are GL functions? Yeah, it's something like this, huh? GL, EGL image, target texture. Is that what we're calling? Yes. How confusing. So this is from Glez to GL2X. Are we, like, allowed to include this file? It just feels wrong. It all feels wrong. It does seem like they're allowed to do this, though, so I don't see any reason why. Maybe let's just try hucking this in here and see what happens. Like, if I'm just like, yo, slam that shit. Like, what happens? Error expected. I'm sorry. Maybe I need to include not just the extension header, but like this. Yeah, looks like it. Okay. So now we have this. And we can call this with our EGL image. And then can we call, like, GL error here? Like, I don't know how to know if it fails. Like, surely... Like, does somebody define this function and, like, the failure condition? Like, hello? Error. The error invalid operation is generated. So I think that means that we have like GL get error, right? Is what we're supposed to hear? I don't know, man. This is the only thing that makes sense right now. The only thing that makes sense. Okay. Let's just see what fucking happens. So do we need to L Glez as well now? Maybe. GL. Like, are we just like... hold on. Glez 2? ls user lib gl glez v2, surely, right? Surely. L glazing, W glazing, this shit is getting out of hand. Alright. I don't know, man. Cross. He's still mad. Let's try the, like, dynamic version of this. So in here, they were calling to does. They called EGL get proc address, which is even more confusing, by the way. Even more confusing. So this thing needs to get cast to a... What is it? It's like... GLP function EGL image target texture to does proc, right? It's this one? To does. So const this is equal to, is one of these equal to this? Let's try that. All right. This is mad because what? Expected this thing found that thing. So C uint any opaque. Do we do like a bitcast? No. Pointer cast? Okay, there we go. Cannot call optional type. So here we're just like, I fucking hope we have it. Okay. Okay. Let's fucking see what happens there. I don't fucking know, man. Why is everything so fucking hard? Alright, let's just see what fucking happens. Swim. And so this won't happen until someone connects. So the fact that nothing is exploding is like a really good sign to me. Really good sign, right? So now, I mean, we could confirm this is being, oh, we had a print here on get error, so we can just, yeah, there's just 0 being printed, which means that nothing bad is happening. Nothing bad is happening. So we should be able to now take this thing and render it somewhere, right? So we need to, can we just for now, can we pull in like stud render, is this thing off by default? With GL is false by default. Yeah, so can we just do like with GL is equal true? And then here we should have stud render. Here we go. We should have some sort of like XY UV program. And there's some sort of like image render in here. Nice. I don't really... We can make this work. We can make this work. We can make this work. Okay, so we have like a GL alloc is a stud render GL alloc initialized off our root allocator. Then this thing eventually does have to get, you know, freed or something. We use this guy here. And what does he want? He wants a color space. RGBA, surely, right? Okay, so this is our image renderer here. And I hope that this just kind of works the way I want it to. We'll see, though. What is this piss about? Error unused ignored? I can fucking see it not being ignored. Unused local constant. Oh. He's just confused. He's just underlining for shits and gigs, I guess. Image renderer is image renderer. Hopefully these types all work in a way that aren't fucking annoying, but we'll see. Image renderer is stud render XY this image renderer. And then how the fuck does this thing work? We should just be able to call like self image renderer render. We need to pass in an explicit texture, which we have, right? We just pass in this guy. And transform, can we just do like identity for now? Just fill the fucking screen. I just want to see what happens. Okay. That compiles, which is good. He's mad about missing GL symbols again. This is fucking annoying. So up until this point, we've been able to just use GL extension functions just like, you know, without having to do anything. But it looks like whatever GL is in here needs those, in fact. Which is annoying. I don't know why that is, because like, if I just look at exported functions on my libgl, I have these. If I like, you know, Zig build, right? This compiles. Bin Swayland client. If we just look at like LDD or like grep, like, what is it even complaining about? You know, something like, oops, grep this thing. Like, if like this is just in there, right? But if we look at the one that we have from, oh, the fact that it's related to Gulvind is interesting, by the way. We should double check that. But if we look at what is in like in our Linux vmenv rootfs userlib libgl, what the fuck? What do you mean no symbols? What do you mean? Do I have to do this in here? Hello? What do you mean? It has to have symbols. It exports them. It's a shared library. What do you mean no symbols? The fuck are you talking about? Oh, that's annoying. Readelf-D? This is not the one. Okay, can we do like APK search Golvund? That thing's interesting. I think that's like a GL dispatcher. That's where our thing was coming from, right? Like, it could be that this just isn't in here, I think. Yeah. What is that? GL neutral dispatch library. So is this like not in like Alpine? Is this just not there? Yeah. Okay. So that explains it, right? That this is probably acting as a loader as well. So we can, I guess, we just have to fucking do actual. Do we use like Glad? Glad OpenGL. This like is how people do. They get all of the extra functions through this thing, right? Right. So we just like use a Glad generator and then include this thing manually or something. It's like something like this. Open GL core common. Just like new OpenGL and new EGL. Right. Let's just get kind of fucking crazy. Right. Something like this. I don't remember. I thought that these things were unnecessary after after having done this a lot of times. It's like, wait a second, we never needed it. But I guess we did. How annoying. Dude, look at that sick download speed. Fucking 20 kilobytes a second. Let's fucking go, dude. Glad 8-zip, yeah. That's indicative of something. Okay. So in here, do we have like grep RI? Like, what is a thing that's failing? Yeah. Okay, so this is now the owner of GL header stuff. Does this work with Zig? I actually have no fucking idea, dude. So can we just be like, so instead here we include Glad? Is that what we're supposed to do here? Right? It's like, yeah, Glad GL. And then just kind of like fuck all this shit. Yeah. Sure. And then we put Glad in here. And then build for a second. I don't know if this is like will just happen to work. Glad not found, so add include path source. This is for the wrong thing though. We want to do this for this. Include nested too deeply. Why? Oh, because it includes itself. Fuck me. Let's just do include here. We'll add source include, make dir include, put this thing in there. Zig build. Glad gl.h not fucking found. Why? Did I fucking do this wrong? Source include glad. Oh my god. Fine. Okay. So now glad he's like, you fucking need that fucking function that you didn't fucking have because you didn't put it as part of your fucking loader. So here we also want like glez2, right? We need. Can we search for to does like import? What the fuck is this extension called? This is like image external. Image external. Like, what the fuck? Glez? Do you say like give me fucking glez too? Yes. Okay. So now we have this as well. Generate? Generate. I guess we download this one now. Glad 9, baby. Let's fucking go. Kill me. I hate doing environment and build shit. All right, let's try that. Really? Still no? I fucking saw it in there, no? Am I high? Rep this alright 2 does here. Are we like missing it somehow? Oh wait, maybe that was the wrong image import. Image external. Image external. Do we have to manually add this one? Maybe. What is in this? 2 does. Yeah. Okay, maybe we just have to like manually add that one, which is super cool. Generate. Glad 10, baby. Bum, 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 bum. Ah! I'm not mad. I'm not mad. I'm not mad. This is just a part of doing development. Glad 10, baby. Boom, boom, boom. Zig build, please. God. Fuck. GL has no member named this. Oh, but I added it. Oh, we also have to compile these files, by the way. 2 does. That's right here. PFN EGL image get target texture. Oh, we can just call this thing now, by the way. Now that we have it with Glad, right? So we don't have to do this anymore. We can just do it like the normal way now. Because Glad is loading it for us. I must be missing something. Glad glez to. Oh, wait. Who is importing Glad here? Glad here. Do I need to glez too? Maybe? He's mad? Glad? What the fuck? Oh, maybe this? I don't know, man. So if GL3, he's like, you've already fucking included this shit. Oh, maybe because I'm including EGL stuff as well? Or maybe this stuff has to go at the top? All of these are likely. What the fuck? If indefinite header? That shouldn't matter, right? Because this should only be included once, but yeah, I guess. Or Glez2 pulls GL? Maybe. So this is in Glad GL. Yeah, it's like we can only get one or the other. Okay. So now we have undefined symbols, which is good because now we can just add those files. So somewhere we should be able to be like exe add Caesar's file source glad source glez2. Okay. And exe add include path of source glad include. Okay. Nice. So that compiles. But the cross compile thing is still broken probably because we didn't actually change we have the same problem in like the standard library stuff. So we'll just hack it for now. Right? This is going to include glad gl.h. And this is going to we just have like some hacks to apply here as well. Include I don't know, man. Can we do like dot/// source glad? Like, does this work? Glad GL not found. Great. ls source. Oops. Yeah. Can we change this to maybe like this? Maybe it's not supposed to be relative here. It's like current working directory as in where the build is running from. That is closer. GL has no this guy. Great. So that's probably defined by some fucking extension. Oh my god! Like, what the fuck? I guess we need to figure out where that's defined now. I hate everything. Like, how come when I search this, it's like not even... Here we go. Like, some extension defines this then, right? GL arb? What the fuck is arb? It means that we're missing some extension. Can we just fucking yoink them all? Fucking kill me. Like, arb. Just fuck it. Fuck it. Add everything. I ain't no bitch. Just fucking give me the world. What are we building? A window manager. Window manager for Wayland. Oopsies. Glad 11 now, surely, right? Zip. All right. RM-R. Copy paste this over here. Fuck this shit. Rename this to Glad. Zig build. Please. Fuck. Okay, so now we just have to, like, compile this shit. So this is happening on the client too now. Everything is getting fucking infected, dude. Everything's infected. So we just need this to be in the client as well, but that's fine for now. Boop. God fucking damn it. All right. This is the problem with hacking, is that you, we also want gl.c, I guess, huh? Shirley. Don't call me Shirley. All right, that better? Duplicate symbol definition. No way. I have to pick? I have to pick one. No way. No way. You're telling me Glez 2 doesn't have GL vertex array vertex buffer, but GL doesn't have 2 does? Wait, but that's fine. I think that's fine too, actually. We just go back to, like, resolving that shit manually, right? Right? We could do that. We could do that. It was like, we do like this, we do like this, we do like this. You know, we did this is a gl.pfn, you know, egl image. This thing is a pointer cast from gl egl, what was it, like, function create something, egl search for fucking function name, egl get proc address, and it's like, of this guy. Please God, that's gotta be it. That's gotta be it. Oh, we're so fucking there. Cross compile now also work? Oh, let's fucking go. Let's go. All right, so we've hacked the fuck out of it. Do we, like, run still? Fuck. Fuck. So this is in shader program Zig 228. He's trying to use compile link program, and oh, we forgot to load. Wait, yeah, we forgot. In main, we have to call glad. We have to say fucking init my shit. Glad load. How the fuck am I supposed to use this again? Glad load GL. Okay. Has no function, glad load GL. It's like this. Okay, and then he wants... Hello? What is this? Can I just write null here? Surely. Oh, but he doesn't have this thing. Can we just fucking import this fucking... Fine. Fine. You can't make me do something sane. Fuck! He needs a fucking window. What goes into this thing? GladLoad GL. What is it? It's like a function that we can call to get the window address. So we need to provide that. What is the window address? It's like the GBM window handle, right? It's like EGL get proc address. That sounds right. He's like, what function do I call to look stuff up? I could get behind that. I could get behind that. Let's go! Let's go! Okay, so nothing's really happening. Okay, let's so until we attach, we get our color, right? Then this thing starts like freaking the fuck out because clearly he's just failing to load the texture correctly, right? We're trying to render this texture, he's freaking the fuck out, right? So what does this render do? He is... Where does this texture go? Render texture, he has texture here. Surely this is not right, right? The fuck? So this is known uniforms comes in, and known uniforms... Oh no, wait, this probably does the right thing, actually. He probably finds... He probably does like a texture attach somehow, magically. So options is here. He calls render inner options. Resolve uniform type, apply uniform at location. And if he sees an image, he sets the active texture and then binds the texture 2D with that thing. So that should work, theoretically. But it's not working. It's not working, but that's okay. Let's start with trying to, at the very least, give him a transform so that, at the very least, it's not taking up the whole screen. So then we should at least be able to see like a black thing in the center of the screen, but the red still kind of working on the outside. I fucking close the VM again like a fucking dumbass. Every goddamn time. Every time. That's okay. Okay. Hurry up, hurry up, hurry up, hurry up, hurry up, hurry up, hurry up. There it is. Cross compile, copy that shit over, run the window manager, see red, oopsies. See red, attach a client. Right, so here is what is supposed to be happening here is that black box is supposed to be the texture that we imported, but it's not, right? So like, what the fuck? I guess it's possible that like... Okay, let's look at GL error here again. Maybe now it is erroring. So let's start there. Std debug print error this. And then can we also do this for EGL as well? Like, I don't really trust anything. And then can we do like GL after, EGL after, and can we do this like before as well? I just like don't trust shit. All right. So we run our window manager, we connect a client, he fucking slams this in here. And so here we're seeing no change in errors, which to me indicates that like it's, and let's just call like EGL clear. Like, is this supposed to consume the error or what? You know what I mean? Is it just like, it could be something like that. It could be that it's like we're only ever calling the same fucking function, and so it's always just getting how do I say, like, the same error code out. It's possible. Possible. The fact that EGL error is not 0 is concerning, right? But I mean, down here we're calling EGL swap, so I don't think it should be. I think this is a GL thing, not an EGL thing. That's kind of what my gut says, because it starts with GL. So can we look at, I mean, we could also look here, right? Error. So what does this guy do in his example? He doesn't check the error at all. He doesn't check the error at all. This is not helpful. Okay, so it also could be this shit, right? Where we were supposed to how do I say this? We were supposed to not use our own texture here. It's a definite possibility. It's also possible that like using this thing from non-OpenGLES context is like fucking crazy as well. Don't really. I'm hesitant to believe that I'm supposed to be using this API, by the way. Is there another way? Can we like dump EGL image to a pixel buffer? Like to like EGL dump image, EGL image to CPU. I would be interested to know, like, bisect where the failure is coming from. They're saying bind this shit. Oh, interesting. Wait, hold on. Hold on. Hold on. That's not a crazy thing. Use this texture target for now. Fuck. Fuck. Glez 2H or something. Hear me out. Hear me out. Hear me out. All right, let's see what happens if we do that. Hear me out. So we bind it to the OES shit. Then hopefully that like sets the texture internal data so that we can use named rendering like normal. No. Okay, but we could try, now that we are in that state, we could try, oh no, this is getting mad, right? GL before, GL after. Can we look at this? Okay, so he doesn't like that. That's what we're learning, right? So before, at the very least, he would bind correctly, I think. Right? He is, at the very least, not angry. Not angry. Okay, so I want to try reading the pixel buffer from this thing. So they're saying in here, you can just fucking GL read pixels. This has to be like from the bound frame buffer, right? I just want to know like who's doing the wrong thing here, you know? GL read pixels, return pixel data from the frame buffer. Yeah, so you have to like bind a frame buffer with this thing. Do they have... Sure. This is all correctish. This is all correctish. So here we could theoretically create a frame buffer. Don't care about this. We generate some frame buffers into this thing. Then we call GL this, and we attach a texture to the color attachment. Okay. Cool. Then we read it back with GL read pixels. And what is it unhappy about here? By the way. Like, this is fine? Not fine. Like, is this not... Was I copying some, like, bullshit ampersand? No? What the fuck? Invalid token? What? What is it talking about? What do you mean invalid token? Oh, it's one of those like fucking copy pasting from the internet shits again, huh? Yeah. Okay. Yeah, is it the space? It's the space. It's the invalid space. Cool, 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 cool. Cool. Love that. Okay. So we're hoping to see what GL bind frame buffer. Can we do this? 640, 480. We're like var pixels is a bunch of u8s is equal to scratch. I don't have scratch. 640 by 480 u8s is equal to 0 or something. Times 4. All right. Does that compile? Splat 0. And then is this actually going to fail? Is this going to Stack Overflow? 640 times 40 times 4. That's 1 meg. We have 8 megs. We're good. We're good. And then I guess I want to dump the pixel somewhere. Try f, try const f is try sdfs open file. Current working directory, open file. Test bin. Defer, F close, F write all pixels. All right. Just fucking start there, see what happens. Create file. I assume that this will look like garbage, by the way. I assume. But it's always worth double checking. All right. So can we do a little SCP root at localhost test bin back? Okay. Hex dump test bin. Those are values. Right? That's interesting. That's not nothing. That's like very much not nothing, right? So that's a good sign. That's a good sign. Can we do like a little, you know, import from PIL import image? How do we do this again? Image PIL image from binary data. I forget. We've done this before, but I can't remember. Fuck off. Image open with bytes.io, byte data, and then do we... Shut up. I don't give a fuck. Holy shit. Oh my god, I'm gonna lose my fucking mind. Can we just do, like, with open test bin as F or something? Like, bytes.io is just this, right? So can we do this? Right, image? Like, what are we fucking looking at? Python 3 packages pillow, I think, is how we get this. No capital P, I guess. Lowercase p. This is a question for the idiot. I have some raw RGBA data in a bin file on disk. How do I open it with pill? There you go. This is what I want. Sure. Yeah, that works. That is what I want to do. If you say so. Width is 640. Height is 480. We have width by height by 4. Open. Test bin. Image save. Test PNG. All right. Okay. XG open. Test PNG. That's a very good sign. A very, very, very good sign. Right? So this means that the texture that we have is a valid texture. We have it somewhere. Right? That's really good. Really good. So now we can focus on why the fuck our rendering is wrong. Okay. So Monkey's like, huh, that worked first try. Yeah. Rendering. So it's actually quite surprising. I wonder if it's like some bullshit with the expectation that, like, when we start this thing, that it's unbound. There's a real possibility there. It could also be that this is just fucking broken. It could be that we're just doing like we're just using some broken shit. Can we try rendering like something else? Can we go like stud render make texture from RGBA? Like, let's try this for a second. I believe you need to use texture external because the spec says that texture 2D invalidated all pixel data. But isn't that fine? Like, it invalidated the old pixel data, but isn't the new pixel data, like, there? Or are you saying, like, texture Okay, where would this have been? This would be in here. Okay, so what are our things here? Is this the guy who defines this function? EGL image target texture. This is not what we're using, right? We're using EGL image target texture. Okay. It's in the non-external extension spec. Okay. So you're saying this guy? We're adding this guy. Yep. And okay. You're saying somewhere in here, target must be texture 2D, image must be handled to valid EGL image, great. Blah blah blah. Okay. All properties are taken from the specified EGL image. And any existing image arrays are free. So that was what I was reading, and I was thinking, like, that's fine. All the pixel data in the buffer used as the EGL image source resource, i.e. the buffer parameter past the EGL image that returned it will become undefined. So he, like, yum eats this thing. He, like, converts the EGL image into the texture. Currently target must be texture 2D. Must be the handle of an valid EGL image resource. The newly specified texture object will be an EGL image target of the specified this thing. An application later respecifies any of the image array in the texture object, such as calls to text image 2D or generate bitmaps, or setting this thing to true. Implementation should allocate additional space for this stuff. I don't see anything in there that, like, makes me think that it's gone. You know what I mean? It's like the stuff that used to be in the target would be wrong. But, like, it doesn't feel to me like... So the fact that we can read out of this frame buffer here indicates to me that everything's okay to some extent, right? Like, that wouldn't work. It wouldn't work if the texture was invalid, I would have thought. We bound like we bound here our texture as GL texture 2D. You know? Okay, but obviously this is still broken. Okay. I would be interested... I think that I want to try rendering literally anything else. Right? It could just be that our image render is broken. That seems like kind of likely to me, to be honest. So I would love to do something that's like GL, or we have like in our render library, like make texture from RGBA. And can we just do like this for a second? Can we do like this? 640 by 480 by 4 U8 is equal to... Can we just splat a 1 in there? Just fucking give him a white box? White text is this. You know, something like this. Is this wrong? Make texture from RGBA 640. Right. And then can we like pass this here? white texture here. Like, can we render this? Fuck everything else we're doing. Like, what if I'm just like self white text here? Render that shit. What does this think this about? Oh, oops. Like this. So if this works, we should see a white window when we connect this thing. Which we're just not seeing, right? So it like seems way more likely to me that we're just like fucking, this is broken. Right? Like just fuck doing anything related to anything. Right? Literally comment out all of this. And actually we can just do this outside the loop. Then it should happen immediately. Right, like this. That's so funny. Yeah, this is just fucking busted. So it could be... There's... Okay, so the transform stuff is working, right? We change this to 0.1.1. This thing gets smaller. Right? Right, he's small in the middle. So it's more related to the texture stuff. Now, can we also, let's hack this image sampler thing. Let's check our UV coordinates. Right, so we should just be able to change this thing to be like this, right? We go vec4 x, y, 1, 1 or something, 0, 1. And we should see like red and green kind of like along the axes of the box. Which we do. So the UV coordinates are correct. So it's the binding of this input image, right? That's the problem. So how is this supposed to get resolved? Render texture calls program render. Render with extra gets in here. He's supposed to eventually go through each option. And he's supposed to say, yo, if this thing is an image, let me return the image. Okay, so this is the texture ID. Then this guy is like, yo, if I'm an image, let me make this my active texture, bind that texture as a 2D texture, and set the uniform to this thing. So can we say bound active texture this to location this with texture ID this, right? This should give us some information. So this is lock T T is here, and this is texture unit active texture. All right, let's just see if that's even fucking happening. Because if not, then there's like another bug somewhere. Bound active texture to location 1 with texture ID 1. Wonderful. Wonderful. So then, like, what the fuck is the problem? Oh, oops, this should be 255. My bad. My bad. Drawing incorrect conclusions. Okay, so that's good. We have proof now that our renderer can render a texture that we've defined to be all white, right? So that's pretty interesting. So it's specifically when we try to use this texture. We know that we can bind this texture to a frame buffer and read off it. Right? We know that worked. So it's specifically trying to use that texture as our input texture here is wrong. Right? So we have like inner is texture here or something. Let's just double check. Unless we were doing something stupid before by mistake. But I don't think so. Oh, we have to connect our client. I forgot. Right? So here he's like, I bound active texture here to 1 with 2, and that active texture is like GL active texture 2 0. I'm pretty sure it's like the definition there. (8.4)E0. Where do we have a Python? 8.4E0. 3.4. Whoa. Hold on. Where is that log? Where is that log? How does this like texture unit allocator work? What the fuck is this thing? He returns, oh, texture 0 plus. Is that wrong? That feels wrong to me, no? No. Learn OpenGL textures. I seem to remember there being something like active in there. How do you connect a texture to a uniform? How does that shit work again? Oh, it's called GL active texture with GL texture 0. So here we call activate this texture with GL texture 0, I assume. Right, so that's what this is. 33984. 33984. Yeah, so we've kind of bound. We've said texture 0 is this guy. We bind that texture from our texture. And then how does the uniform work here? They just set it to 0 or 1, right? So 0 is like texture 0. Seems reasonable to me. Seems reasonable to me. So that's confusing. It's interesting, right? It's like we both have this texture and we've proven that we can read from it with GL texture 2D here. But when we try to use this, it's no good. So I wouldn't be shocked if it was something about like that extension and how you're not allowed to use it directly for rendering like that. Maybe you can only attach it to a frame buffer or something. Here's what we could try. No, never mind. I was gonna say you could render to another texture and then try to render that, just as like a test, but we can't. like, are there limits on what you're allowed to use this thing for? That could be something, right? Where, like, this thing is only allowed to be used in some contexts, you know? For creating texture and render buffer objects, using storage would specify this. Blah, blah, blah. Oh, I guess also its pixel format could be, like, totally fucked, right? How does our fragment shader work? Like, he's calling texture on this thing? But, like, are we supposed to set the format and stuff? No, it said that he sets the format, right? Width, height, format, border are all taken. Okay. Could be, like, mip-mapping stuff, theoretically. Can we force our fragment shader to sample from a certain mipmap level? It's texture mipmap level fragment shader. I feel like that's allowed somewhere. Yeah, can we do this? I want to try this, just on the off chance. So this is normalized, great. So if we just, like, force it to be texture 0, like, map 0 here, I wonder if that changes anything. You know, we're hopeful, but you never know. Oops, wrong one. Yeah, so still no dice. Still no dice. I don't know what to do about this. It feels like we have, like, the two pieces in place. We're just missing a bridge between them. I just also want to double check here if we go back into this thing. Renderer. Like, of course, if we use white text here, right? That still goes back to working the way we expect. I assume. But worth double checking. Yeah, okay. So there's something wacky going on here. I think I have to call it. It's 4:40. We've gone, like, way over time. There's something left to figure out here for sure. I don't know what, but there's something. But we'll call it. I think we're close. We have proof at the very least. Test.png maybe? At the very least, we have proof that we have got this thing into a texture handle that we can read. It's just more about why the fuck can't I render it? So, cool. Thanks for watching, guys. Apologies, we didn't quite make it. I was hoping we would. If you like what we saw, we stream most days. We're able for 12:30 to 4 o'clock Pacific time. It is 4:45 now, so anywhere between 4 hours ago and now is when you should expect to see us live. I need to eat breakfast, so I'm gonna go eat some food. Thanks for watching. Patreon, YouTube, Twitch subs, YouTube subs are all a good way to support if you wanted the content to continue. Yeah. YouTube, peace out. Twitch, let's find someone to raid.